All right, it says we're live, which means that I want to switch over here to Sudoku. If I hit play on here on my phone, then it should be. Do I need to refresh? There it is. Hey, it's working. Awesome. All right. Yeah, then we go over here and we just start solving. So we are doing a puzzle from last time because we didn't finish it before 10. So equal sum arrows by Samantha, in parentheses Anu. Normal Sudoku rules apply where arrows point from the same cell. The sum of the digits along the two indicated diagonals from that cell to the edge of the grid is the same. And we noticed that if we look at this diagonal, or this equal sum arrow here, that these two match with this. And these two match with this, and these two match with that. And that gave us... Oh, and I guess also this one here matches with that. So all of the blue sums to the exact same as red. And there was also some limitations in what could happen with like these two, because let's see. Well, the minimum in blue, if I just highlight it, this is minimum 6. That's minimum 6. And we've got another 3 there. So 6 and 6 is 12. Plus 3 is 15. 16, 17?
Which would have to be 8, 9 for red.
And that places a 1 here, 1 there, a 2 there. That's not a 1.
Well, and the green arrow in box 4, that has to be 7 and 9 because it sums to 8, 9.
Right. And let's see, this is 6. And this is either 2 more for 8, or 3 more for 9. But this is 6. So this is either 4 or 5. And if we look at this diagonal, if I minimize these two, that's 3, 4, 5, and another 4. Oh, excuse me. 3 and 5 and 4 makes 9 because of this arrow here, which means that those two groups are the same. Okay, so it should be good with the coloring. And where do we go from here?
The 8, 9 pair in box 3 is resolved.
8, 9, 3, and 1. I just forgot right here that this was minimized to 5, plus 4 is 9. So then 6 and 2 makes 8. And now these three are these two, according to these two green arrows. And that's 4 and 8, which is 12, which has lots of options, but I'm going to go ahead and put those in. They can't both be 6. This isn't a 3, and that's not a 9. Where's an 8 in this box? It's not along the top, and it's not there, and it's not there. Although I guess that's less helpful than I was wondering. But it does mean that the largest that this can be is 6. Meaning the largest with those two is 15. So that, for those three, are maximum 15. Well, I guess we can look at this one, because these two here are going to be those. And if we look at these two arrows, I can change this direction. And the maximum that these two can be, well, this one can be an 8, but this one can be max 6. So that's max 14. And we'll put an 8 there, because it sees the 9 up here. So those three are all of this. And, well, minimum, well, that would be 6, but this would be 3, 4, 5, which is 12, so that's 18. $19, $20. If we look at the minimums.
Yep. And the blue there is max, is the max, and it's 22.
So that gives us 2 degrees of freedom. 6.
Yeah.
So that would go down 2. And this goes up 2.
Well, we can place a 2 in box 6.
Along top, not there. There's 2. Can we do the same in box 3? Not quite. It has to be one of those. Where's 3 in this box? Those. Where's 3 in this box? Okay. What's remaining in here? 1, 2, 3, 4, and 8. Okay, well, we know that this group and this group is the same. This is already 11. And I guess minimum's 1, so that's minimum 12. But 6 and 7 is 13. Hmm. 1, 1, I can't put 8 or 9 on these, so that puts 9 in one of those two positions and 8 in one of these two positions. 8 and 9, where this isn't a 9 and that's not an 8. And then I guess I just realized that neither of those can be a 7.
In in box 6,
Box
the 8 only
6.
has 2 spots it can go in now.
Can't go in the middle, can't go on the top, can't go there, and can't go there. So 8 pulls the 8 out of here, and it's placed here, placing a 9. Okay, so that placed those. We've got a 9 on this side. 8 is in one of two positions in box 2. Who's in the middle? Go ahead.
Blue arrows that come up from box 8, they're blue on coming up on the right. That's
Uh-huh.
minimum 17.
Yeah, but it was max 22, and then red was minimum
Right.
20.
Okay, so nothing has changed on that. Okay.
Yeah. Yeah, we've still got 2 degrees of freedom. If this is a 6, oh, well, this can't be a 6. Because if it was, this would have to also be a 6 and an 8 for 12 and 8 to make 20. But if this is a 6, that can't be a 6. So this is an 8. That doesn't use up any degrees of freedom. Because it couldn't be a 7 because of the 7-9 pair.
Right, yeah.
And so yeah, so then our 2 degrees of freedom are either in here or they're in red. And so we can have 6 and 6, and that would be fine. Or we can have 5 and 7. That would be fine. Or we can have 8 and 6, or 8 and 5. Or 6 and 7. We've got lots of ways to use up our degrees of freedom over there.
Yeah.
If either of these are a 6, they use up our last degree of freedom. Because this would have to be 5. 5 and 6 is 11, plus 3 is 14, but this is minimum 12. And a 5 uses up all of our degrees of freedom. So does a 4. Well, no, a 4 would only use 1 degree of freedom. Except I only have 2 degrees of freedom, which means the maximum here is 8. Which means I have to use a 1. Because if I didn't, then 2, 3, 4 is 9. And going from 6 to 9 uses up 3 degrees of freedom, but I only have 2, so I have to have a 1.
The reds coming up from the corner of box 5. Well, 6, it's minimum 13, right? But if you go up on the left.
Yeah, 6 and 7 is 13.
Well, that's now. That can't be a 2 anymore. Could it be a 1? No, because the other's minimum 13.
Well, the minimum would be 1 and 11, which is 12. But I could put a 5 and 7. Yeah. Three, 4, 5 would allow this to be.
If that's if it can't be 3 and 4 in box 5, because the 3 would have to be in cell 3.
Yeah.
Which places the 3 there. So the 3 would have to go up in the corner in box 3. 3, 4, that now becomes 8, minimum 8.
Okay. But that's fine within our degrees of freedom. It would just take all of the degrees of freedom. With this being 8. 3, 4, and 5. Oh, what you're saying is
that's already 20. Right. Oh well.
But if this was minimized, this would have to be 3 and 4. Because that's the only way that works, to minimize that down to 7.
Right.
7 and 6 is 13, but this being a 3 places a 3 there means this is 4 minimum, and that can't be 6 anymore. Yeah, okay, I see what you're saying. Although I guess this would still be minimum 7. 1, 2, and 4. You can still have a 3 in one of these two positions. But that would bring up our minimum to 14.
Right.
What else? Because we've got these 3 here. This is maximum 8. Well, if those are 8, then this has to be 7. Which is 15. Because if this is 8, then this must be minimized. But if this were 6, then this would be 9. because you'd have to place the 3. This would have to be a 3. And 9 and 6 is 15. So if I said that that was the maximum, or I guess if I made this the 5 and I used up 2 degrees of freedom in there, that would be 7 plus 2, which is 9. Yeah. Okay, so 15. Although, whatever, that's neither here nor there. Then you could do 5, 9, and 1. 6, 7, well, and 2 wouldn't work. But you could do 5, 7, and... Well, the max would be 4. So this must be 1 or 3. If this isn't a 3, then you've got 4 and 5 and 6. 4, 5, 6 is 15, but that would be too many degrees of... That would take up 3 degrees of freedom, which we don't have. We only have 2. So this actually has to be a 3, which makes this 3 and that not. And now this is minimum 7. And since I've used up 1 degree of freedom, that takes that off. And I think this has to be a 2 now. Because if it was a 4, it would use up 2 degrees of freedom, but I've already used 1 here, because this is minimum 7.
Right.
So now this is 21 or 22. Because that was minimum 2. This was minimum 12, and it might still be 12. And now this is minimum 7. But that couldn't be a 3 because that was row 6.
Row 6 now has a 5, 6 pair.
Four, 5, 6 up here. Four, 5, 6, and 7. But 4 has to be one of those two. That's not it. 4, 5, 6, 7. Okay, so these are either 9 for minimum or 10 maximum. Because there's only 1 degree of freedom left.
Right, so the center one can't be a 5.
Right, so this is a 4.
Or a 6. Yeah.
And we've got a 5, 6, 7 triple here, leaving 5, 6, 7, 9, 2, and 1, 4 or 8 there. But we do have 7 here guaranteed. And this is now 7 or 8. So this is either 14 or 15. Fourteen could be 5, 6, 3. 6, 7, 1, which wouldn't use a 5, but it would use the 6. But you would have, if you used a 9 and a 5, that would have to be a 1.
Yeah. The in box 6, the purple arrows that come down from the 3,
Mm-hmm.
coming down to the left, it already sees a minimum of 14.
1 and 3 and 10. So 14
Be 5
means
and
this is 8 or
9.
9.
And it
But
can't
since
be
it
8.
can't be an 8, so that would be a 9. So this has to be 5?
Well, if it's 6, 10.
Well,
'Cause
this
it could
has to
be
be
0 and
9.
1. Right, yeah.
Yeah. Now, I was looking at, I guess let me clean this up for a sec. Okay. I was looking at these two. And if this is a 6, it uses up the degree of freedom left over and would force this to be 22. But because that uses up our degree of freedom, this can't use any degrees of freedom, and so this couldn't be a 5. So this is forced to be a 5, and this is 6. Because they couldn't both be 6. And if this was a 6,
Right.
it would force that to be. So this had to stay minimized. That has to stay minimized because it couldn't be a 3. So now our degree of freedom is either used up here, meaning this is 7, and this is 7, or this is 8, and that's 8. Which actually means, because this is 14 and that's 14, we can remove those. Blue and red are still the same.
Yeah, well, cell 3 up there can't be 4 or 5.
Right.
Because it's either 1, 2, 4, 1, 3, 4, or 1, 2, 5.
Yep. And this is 15, and you said this was minimum 14, which means this isn't an 8. And this is 1 or
So those
2,
have to. Well,
but it can't be a 2, so it's a 1.
right.
And this is 14.
Right.
Or excuse
So
me.
4.
Yeah, this has to be 15 now to match that.
Mm-hmm.
So then we've got 8 and 3, and not a 4 and not a 3, not an 8 anymore. And the leftovers, 4, 5, 6, and 7. Middle two aren't 4.
Box 9 can
And
place the 1.
place 1 or 1. And this is 13 or 14, which means this is 13 or 14, which means this is either 10 or 11. It can't be 10 because all of our small digits are out of the way. This has to be a 5, 6, which means this has to be a 5 to make 14.
Right.
And we've got 7, 8, 9, where this is an 8 and this is a 7, 9 pair. This one, not an 8. And these are 12. So 4 and 8, but you can't do 9 and 3 anymore. 5, 7, 5, 7, or 4, 8 in that direction. Okay. This is not a 5.
Placed in box 1.
1 and 1. There. Oh. Not sure that fixed this yet. We've got 7. So 1s are out of the way. Well, this is minimum 14. This is 14 or 15.
Right, it's 14 or 15.
And
So
since
that's
this is a
13 or
1,
14. and it can't be 14.
So it must be 6, 7?
6, 7, yeah.
And since that's
So
13, this must be 13. Subtract. Excuse me, this is 14. So
right,
these are 7. So we've got a 7
right.
here, and a 2 and a 4. Once I slowly do the math there.
5, 6, 7 triple in box 2.
This is 4. Remainder in there 3, 5, 6, 7. And this one looks like it's a 6, a 3, a 5, and a 7. This one should be a 7 because those two aren't. And then I don't see 8 or 9 in that row. 8 and 9. And we've got this remainder. Looks like it's a 4. These two, 8 and 6 in that order. 8 and 4 come off, and that is 12. And these two are 12, so these two are 12. Can never be 6. 5 and 7 come out, and that leaves 9 and 3, which fixes our 7 and 9 over here. 2, 3, and 5, I think. 5, 7, 2, 5, 6, 5, 6, 7, 7, 6, 5, 6. This left over.
2,
And the top 3 are
4,
4,
6, and 8.
6. This one being a 6. And I've got 1, so 2, 3, 4, 5, 6, 7, 8, and 9. Yeah, we did it. Oh, I just realized that I forgot to hit the record button. Well, I can start doing that now. Start recording. All right. Well, that will count for the next puzzle. So, speaking of the next puzzle, let me grab the next video as I remove that bookmark. And I grab this link. And then I move that link over to this window. And that should switch puzzles that we're working on. And if it doesn't, no, looks like it did. Okay, cool. So Diagonal Skyscrapers by Shriek. Normal Sudoku rules apply. Skyscraper. Each digit should be viewed as a skyscraper with height equal to its value. Clues outside the grid indicate how many digits are seen along that diagonal, with higher digits blocking lower or identical digits from view. So if we look at, say, say this diagonal, this digit must be higher than all of the digits that are behind it. So this 6 would block the 5, 4, and the 3, for example. And this 9, this long diagonal here, this top left digit, is actually the smallest, and they increase down the diagonal. All right, well, let's restart this so that we have accurate time and just use that information. Since this digit must be seen, the following digit must also be seen, the digit after must be seen, this one after that, that one, that one, that one, that one, and that one. They must go like that in order to see all 9 of them. From there, six. 1, 2, 3, 4, 5, 6, 7. Which means one of these is not seen.
Well, yeah. Well, you can't have 7, 8, 9 after the 6 because they see 7, 8, 9 in that order.
Right. Which I guess strongly implies that this digit isn't seen. Well, maybe it's just one of those digits, because you could do 8, 9,
Right.
and then you can't see that one. But then these still have some flexibility.
Right.
Now these are
But it
minimum.
does, but not being able to put 7, 8, 9 after the 6 does tell us that that's where the hidden one is.
Right. Because we can't see all of those, which means we must be able to see all of these. So this is max 5, but it can't be 5, so it's maximum 4, which means this is max 3, and this is max 2. With these being a minimum of 4, 5, this ends up being a minimum of 6, because it must be strictly greater than...
Everything else, yeah.
Well, actually, it doesn't have to be strictly greater than, because it's the only one that's seen. Identical digits are blocked from view. This could be a 5. And you see 4 or 5 there.
Yeah.
One, two, three. Well, that's actually not possible, being 1, 2, 3. You have to have a 5 in this group somewhere. Because it can't be 1, 2, 3, so we have to include this one. And that's a 4, but this can't be 1, 2, 3, 4, because that would block that one. So I've got a 5 in this group. So this is a minimum 5 as well. And since this digit exists and must be at most the same height as this one's minimum 5, and it can't be 6 or 9. Now this one sees 5. 6, 7, 8. But doesn't see 3 of them. And this one sees that one. So this is minimum 5. And also not 6 or 9. Wait, this is a very weird loop. Because this cannot see that, which cannot see that, which cannot see that, which cannot see that. These are all the same, aren't they?
Maybe.
Because, well, I guess let's imagine that this one is bigger than that one. Well, this one won't see that one, which is fine. But this one cannot see that one. So this one must be at most blue. And this one cannot see this one, so it's at most blue. But then this one would see that one because red is bigger than blue. But because it can't, it must be at most blue. So I think that proves they're all the same. And where does that place it in the middle box? It's not the top row, not the bottom row, it's not the left column or the right column. So there are 5. And this must be 4, 5. And these are 1, 2, 3, 4. Or that's not a 4, that's not a 3, and that's not a 2. These are all 1, 2, 3, 4, not 5s, because I see 5s. We've got 6 there, and 9 here. And since this digit has 4 digits that are strictly greater than it, it has to be a minimum of 5. Because you've got 5, 6, 7, 8, 9. That would be 5. Now it can't be 5 because it sees a 5. Where next? No, I see 2 of these digits. Yeah, that'll be a bit confusing. There, not there. 5 has to be one of those. Same as up here. Particularly helpful. Well, we must have some Sudoku we can do. Because we've got up here 6, 7, 8, 9. Do we have Sudoku we can do? Well, 6 has to be one of these bottom 2, which means 6 has to be one of these side 2, as it can't go on this diagonal, otherwise it would be seen by this 1.
Right.
Well, we see 6 sees the bottom of this and the side of that, so 6 is one of those two. I don't know if that gets us that much farther. But we just said that 6 has to be one of these two, and we know that that 6 is not seen.
Right.
Which means that this digit is seen. And for it to be the last...
To be an 8?
That's what I think. Because 1, 2, 3, 4, 5, 6, and 7. The 6 is not seen, so that goes down to 6, and that's how many digits we see. Which means we do see this. And that means one of these two digits, which is seen, must be at least a 7. And this is the largest digit along that diagonal, and the largest possible digit is an 8, which is right after the 7. So this ends up being a 6-7 pair, where this is the 6 and that's the 7. 6 is in the dark, the 7 is seen. So that resolves there, and also places an 8 here because of these two 8s. And that not being 1, because of the diagonal. Well, this isn't an 8 then. I guess I do still need to make sure that all of those are in the correct orientation. Two, three, four, five, six, seven, 8. There are 3 which are not seen along this diagonal.
Well, there are 3 along that diagonal that actually have digits in them.
Mm-hmm. The first digit and these two corner pieces. If this is a 4, you can't see either of those.
Right.
If this is a 3, you could potentially see this one. But I don't think you could see that one. And if this is a 2, you could see one but not the other. If this was seen, which I don't think it can be, then this one couldn't be seen. And this is a 4, and let's say that's a 2. That means only one of these could be seen. As being a 3. And that would be all of my dark possible digits. But this could be 2, 3, 4, and then I'm none I haven't gotten
9
anywhere.
can be placed in box 6.
We've got 4 in one of these two because of that, which takes a 4 out of here. And in these, 4 must be one of these two, so this isn't a 4. Well, that clearly can't be a 9, so 9 has to be one of these two. One, two, three, 7, 8, 9. These two are not 8 or 9. These two are not 7. 1, 2, 3. Yeah, 4 and 7 would be needed. One, two, three, 4, and 7. Not a 2, not a 1. 1, 2, 3, 4, and 7. Six is one of those two. Fix my audio real quick. My computer fan started running. One, two, three. 1, 2, 3, 4. We're just so close to. We're just short of a full group. 6 has to be one of these two. What are we missing? 7's up here. If this digit is seen, then there are That would be 1 and 2. There would be 3 more. You could go 4. Well, for there to be 3 more digits, you could go 6, 7, 8, 9. So the biggest this digit can be is 6. But it's not a 6, it's also not a 2. One, two, three, 4. Again, just short of a set.
All right. If the yellow in box 3 is a 4, then you wouldn't be able to see any of the ones, or either the ones in box 5, because, let's see, you wouldn't be able to see the one in box 2. That would have to be not seen. The next, you wouldn't be able to see that one because an 8, 1, 2, 3, 4, 4 would be the max then that could be seen. So that can't be seen. Because if that's an 8, that would be the 4th one that would be visible if the second one can be seen.
Yeah.
So we'd have to say 4, 5. That one can't be seen.
This one
Otherwise,
cannot
you'd
be a
only be able to see
9.
4.
Yeah. We can't
Or
make
an
this a
8.
9 ever. It can't
And
be
it
an
can't
8
be a
if
10.
that's a 4. But I think it can still be an 8
2.
if all 4 of those were seen,
Yeah,
because
2, 3, 4, 8.
8,
Yeah.
9. Because we don't know if this one's missing for certain.
Right. Only if the first one's a 4.
Yeah. But if this is a 3, then only one of these two can be seen. And then I couldn't put a 9 here and an 8 there. Because that would make 3 back here and one of those.
Right.
Because an 8 would only allow for 1, so I'd have to have a minimum of 3 dark back there. But I'm only allowed 3 ever. So this can only be an 8 if this is a 2. And that would be a 3, which makes that a 1. And that a 1. A 4. They don't. 5, 4. I guess that would end up having to be a 5. And that a 5. because I've got 5s in these two groups that have to be like that. Nine is one of these two, so neither of those is 9. So where's 9 in this box? It's here, which means all 3 of these are dark, and this 9 must be seen.
Which means it has to be an 8.
We've got 8, 4, 3, 2. Yeah, 4, 3, 2. There we go. That's what we were missing, is the fact that this 9 took it out of here, forced it to one of these two, and then forced the 9 there. And that should solve the puzzle, because you don't have 5s there, you've got it here. That's not a 3, not a 2. These two are also not 2s. These two aren't 3s. You're not a 5, which makes that one a 5. 1, 8. These aren't 5s because that is. That's not a 4. That's not a 1. These aren't 8. Well, this diagonal is resolved, because it doesn't matter what's after a 9. You can't see it. So it's just this that has to be done. 2, 1, 2, 3 triple. I'm just gonna make that 6 and 9, I think. 3, 4, 5, 6, 7, 8, and 9. Yep. 1, 2, 3. Not quite. But this is a 1, 3, 4 triple, so this is a 6. I knew that already. So this one isn't a 6. Got 4 digits left. 2, 3, 5, 6, 8. This one, not 1, also not 1, so that's a 1. These two aren't 9, so that is. This is 7 and 4. 2, not 2, not 4. 1, 3 pair makes a 4. Those aren't 4s, that's a 4. Those aren't, they're also 1 and 3. They're 2 and 6. And these two aren't 9. That's not a 7. What's left over in this box? 5, 1, and 4. Would leave 6 left over. And got 2, 8, and 9 removed from there. 2, 6, and 9. 2, 3, 6, and 7. 2, 3, 7, 9. 3, 6, 8, 9. And 3, 6, 8. Eight, 9 pair takes an 8 out. And this is a 7. 3, 1, 2. Not a 3. 2, 1, 2. 3, 1, 3. Not 3s. 3, 7 pair. 1, 2, 4. I think I need a 7 and 8. And
Box 8.
7. So we've got 6 and 8 and 9.
Box 2.
7, 6, 8, 2, and 9. 3, 7, 3, 4, 2, 1. And now it doesn't matter because that's all situated. 3, 6, 2, 1, 2. 1, 7, 9. Not 7s. 4, 2, 8, 7. 6s and 6s. Place 6s over here, and these two take them out of the bottom, so we've got a 6 here. What's left over in this row? An 8, I think? Yeah. 6, 8, 9, 6. What's left over in this column? 9? Looks like it. I need a 1 here. 2, 3, 4, 5, 6, 7. And we're done. Nice.
Yay.
That one was pretty hard. I'm actually surprised we got it done in just over half an hour. The did take a little bit to see the 9 in this box, even though I'd already had it marked. But I don't know. That was a good puzzle. So I grab the next one. And here. Nope. That's the same puzzle. Puzzle that starts easy. Got this link. And we move it to this window, and now I can see it. So this is 3z plus x by walking writer. Normal Sudoku rules apply. Digits along an arrow sum to the number in the connecting circle. Digits connected by a black dot have a 2-to-1 ratio, and digits connected by a white dot are consecutive. A gray square contains an even digit, and digits along a marked diagonal may not repeat. Alright. Well, I see the Z's. But, alright, so these are 2, 3, 4, and, 2, 4, 6, and 8. And the rest are odds. 1, 2. You would think I would know these, having been a math tutor in the past. But these, well, some of these are less restricted. So just simply the fact that there are 3-digit arrows means you can't have a 1 or a 3 on them. And the middle one cannot be a 5 because they're all in the same box. But these two could have, in fact, one of them is going to have a 5 on it, because you can do a 1, 2, and another 1 to make that a minimum of 4. But 5, 7, 9...
The main diagonal, those have to be, 1 or 3.
And now this one, because they're connected inside of the same box, I couldn't do a 3, a 6, and then another 3. Well, because this has to be an even digit. So this must be 1 going to 2 going to 4. Taking 4s off of all of those, placing a 3 and a 6 here, which takes 6 off of that. And this is 2 or 8, so this is 1, 4, and that's it. Because it couldn't be a 2, because 2 doesn't connect to 8, and it can't be an 8, because 8 only connects to 4. From here, where do we go? This set of crop.
Black croppedy dot in box 9.
Yeah.
Can't be 1, 2, 2, 4, or 4, 8 because it sees the 2 and the 4.
Right. So
therefore
we've got
it's
3, 6. And this could be 3 going down, except it can't be. So if this is a 3, it must go up to 4 and 5. 6 could go down, 5 and 4, I think.
Uh-huh.
And it could also go up, 7, 8. Now what about this croppy dot? 3, 4, 6, 8. It's not a 1. So it either has a 4 on it, or it's 3 and 6. If it's 3 and 6, that doesn't impact this at all. But if it has a 4 on it, this would have to be 7, 8. Which means that this cannot have an 8 on it. So it's either 2, 4 or 3, 6. But I don't have to have 4 in this whole group, because I can do 3, 6, and 7, 8 and be just fine. This
but
is
if you
1,
look
2,
at the
4.
Kropke dot in box 7 that's on row 8, if that's 4, 8,
Okay.
then that becomes a 5, 4, 3, 6.
Yeah.
And that works, so we're good on that.
Mm-hmm. This has to be 1, 2, 4, 8 because of the 3, 6 here. I don't think there's enough information here to do anything with that. This, because of the 4, can either be 1, 2 or 3, 6. And a 6 is fine. Well, actually, no, it's not. This is minimum 3. So this actually can't be a 6, because that would break this.
Right.
So this isn't a 3.
And since that's a minimum 3, that cannot be 5 in the circle.
Right, because this is minimum 3, and that's minimum 3, which is minimum 6, which means this is 5, and we've got 3, 4. No, can't put a 4 on there, because 4 and 2 is 6. So, or 4 plus 1 plus 1 is 6. This is no longer a 5, which means this cannot be a 4, because you can't go 6, 5, 4 anymore. And because 4 doesn't connect 4 or 7. Yeah, so if this is a 2, then this is 1, 2. And if this is 1, then this is 1, 3. We've got 1 for sure. But this one cannot be a 2, because I would have to use 1 and 2 to make 3. So that's not a 2. If this is 1, then I have to make 4 from those.
Well, the
which
black
could be a
Kropke
pair of
dot
2s.
there can no longer be 1, 2.
Right, so this is 4 and 8. And so this is not 4 or 8. And this cannot be an 8, because that's not a 4. 8 comes off of those 2.
It can't be 4 and 2?
4, 2 here.
No, and the other one that's the 4, 8. Box 7.
Right. So this is a 4.
It has to be a 4.
But this didn't have to be 2. Alright, that's my bad. But since this isn't a 4, this one's not an 8. But it can still be a 1, 2 pair, so that still allows 2. Okay, but we've got 1, 2, and 8, so 7 and 9. That means 7 and 9 have to be in this group. And that 7 must be one of these 3. 7, 9. Because if this was a 7, then this would have to go 9, 8, 7. Which would break the puzzle. Okay. But I could do 9 and 7 and do 6, 5 and be just fine. But I couldn't do a 7 here and do 6, 5. This would have to be 7, 8, 9.
Oh,
If
in box 3, that 7 or 9,
yeah,
that can't be a 7 because 7 is 1, 2, 4, and one of those is in. It sees 1, 2, 4 in the jag above it.
well, this can still be 3,
Oh,
and I
right,
can
right.
make
I
this
forgot that
4.
it's in two
Yeah,
different. I keep forgetting that.
it is really easy to forget. Like the yeah. Does this fix anything up here? If this is a 1, then I have to do a 1, 3, which places a 1 here. If this is a 2, then this has to be a 1, 2, making that a 1. Never mind. Okay. Didn't do what I thought it was doing. Six has to be one of those. That doesn't impact 7 or 9 that much. Where do we go from here? Well, knowing this has to have 7 on it doesn't mean anything, because it can go 7, 6, 7, 6, 5.
Right.
So we could have 8 over here. So what about this? Just like we've got enough information there. With this being minimum 3, to make this a 7, I could do 3 or 5. Or 6. Except that could be 1, 2. So if that's a 6, you'd have to have 1, 2 in all of those. That isn't a 6, it's 3 or 5. Okay. So if I wanted to make this a 7, that's a 3, and that has to be 4. It would have to be 1, 2, 3, which is possible. Three, 3, 1. If this is 9, then I've got 3 and 6, which means this isn't a 3, it's 1 or 2. And a 5, I would make this 4, but it could be 1 and 3 in either direction. So this would be 1, 3, or it's 4 or 5. Alright. If this is a 7, and this is 1, 2, 4. Oh, okay. Well, maybe not O. If this is a 9, this has to have two of the digits from 1, 2, and 3.
Right.
If it's a 7, it must use 1 and 2. But I could do 1, 3, 5, and this can still be 2. But this one of these two has to be a 6. So for this to be an 8, and this be 2, 6,
That would have to be 1, 3, 5.
yeah. So how do we make it that way? I'm not sure. Two, 4, or 3, 6. One, 2, 4, 5. It's not that useful. Although, because this has to have a 7 on it somewhere, you can go up 8, 9, or you can go down 6, 5. These two can't have 5s on them. Can't put 9 in the middle. And this one's not a 6. Nine, 8, 7. 8, 7, 6. 7, We have to go 8, 9. And 5, 6, 7. But if this was a 6, it would have to go 7, 8. Which is fine, I think. If this was an 8, this would have to be 6, 7, 8. Or I guess it could be 7, 6, 5. This would have to be 6, 7 if that's an 8. And then that becomes 3 or 9. Well, because you could go 3 to 4 or 9 to 8. So this would be 4 or 8. I'm not sure. What can this digit be? It's not 3, 6, it's not 5, and it can't be 7 or 9. It's 1, 2, 4, or 8. Okay. But this one can't be 7 or 9, 4 or 5. Also and. What are we missing? I guess if this is 1, 2, 4, then this is a 2, making this a 1 and a 1, 3 pair, which would be a 3 and a 1. So I guess if this is 7, then we've got 1, 2, and 4. This being a 7 makes that a 9, and this a 2, making that 1, 3, and 1. This would be an 8. And this would end up being a 6, 7 pair. But this is a 7, so that's not a 7. So that goes 7, 6, 5. Don't have contradictions yet. So then this 1, 2, 3, 6, 8 couldn't be 6 or 8 or 3 or 1. So it ends up being a 2. Takes 2 off of that. And this 3, 6, 7, 8, 9 isn't a 7, a 6, an 8. So it's 3 or 9, which means this 4 or 8. Oh. All that stuff was if this was 7. But because this is 9, that 2's not accurate. 6, 8. That would have to be a 9. So we need 2, 4, 8. Two, 4, 8, 3, 7, and 9. Have 1, 5, and 6 here. 8 and 6 would be out, so would 1. That would be 2 or 3. Feels like something should have broken by now.
Yeah.
But I don't know what it is. This is 7. Got 3, 3, and 1. Makes that a 2. This is 9. And then what? 1 or 3 must be over here. Well, we know that one of these two has to be a 1. So it can't be 2 and 3 because that's already 5. So 1 would have to go in here. Which I think it's true regardless. Not necessarily. You could have a 2, 4 here. If this is a 9, a 3, and a 2, 4.
Right.
And you could put 1 here, theoretically. What are we missing? Well, knowing 1 has to be here and 1 has to be there, this isn't a 1. If this was 3 and 6, 3, 5 is 8. That would be a 1. Which would force 1 in here now. Oh. 3, 6, 3, 6. if this is 3, 6, then that's a 6. And that's a 3. What can this digit? It's not a 6. It's not a 1. And if it's not a 9, then it can't be 8 or 7. Well, that's not super helpful. Well, 1 on this diagonal can't be in box 1. It can't be here or there in box 5, or here or here in box 9. We have 1 in one of those 2 positions. That's not a 2. That's not a 2. And that's not a 2. I don't know anything else. There's gotta be something obvious.
Probably. Isn't that the way it usually goes?
Yeah. we've got those that are chained together, those that are chained together, this, which has to be 3, 6, because it can't be 1 or 8, or 2 or 4. We know that one's 5. If this was a 3, then those would have to sum to 2, which isn't possible. And these are either both 1, making this a 3, or both 2, making that a 1. So these are the same. Meaning that our red digit is one of those two. So that's either 1 and red, or red is 1.
Mhm.
Following that, this pretty much everything can be.
Right.
This was 3 and 6. Got 5 and 1. 6, 3, 5, 1 would be 9 and 7. 1, 2, and 4. So that becomes a 2. 1s and 3. 8, 4 would place a 4 here. 1 would make that 1. 3 and 6. This would have to be 7. And it couldn't go up to 8, so that would be a 6 and a 5. This would end up being 9. 2, 3, 6, 8. 6, 8. 3, 6, 7, 8, 9. 6, 7, 8. 4, 8. One, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8, 9. Two, 3, 9, but not 3. 4, 8. 1, 2, 3, 4, 5, 6, 7. This wouldn't be a 4, and that's not a 7. That's 8. 4, 3, 2, 9, 4, 8. And I guess this mostly just comes from the fact that this is 7, not that this is 3 and 6. I haven't really touched this stuff. Although I guess the 1 here, this would be 1, 5, 6. But this would be a 2, so that wouldn't be a 2. So that 1, 2, 4, 8. 1, 2, 8. 4, 7, 1, 2, 8. This can't be 3 or 6. And this is a 6, 8 pair, so that's not a 6. Oh, and this is 7, so these two aren't 7. 5, 9. That's a 2. That's not 2. That's not 4. That's not 2. If this isn't 2, then this isn't 4. Okay. If these were 2, we've got a 1, 2 pair here. This is a 1. This ends up being 8 and 1 and 2. This couldn't be a 1, 2, so that would be 3 and 6, 5 and 1. Which, of course, is a 9 and a 7. But this is an 8 because I said these were 2s. And so this is 2, 6, but you couldn't put a 1, 2 here if this was 2s.
Right.
Because you have a 1 here and there, forcing 1 to be one of those because it can't be up top. So we know these are 1s and a 3. Okay, so that's gone somewhere. Three, 6, not a 1. Okay. With this being a 1, 3, if this is a 7, then this is 1 and 3, and this would have to be 1, 3, 5. So this is either 1, 3, 5 or 1, 2, 4. And it's the 4, 7 that float with the 2, 6, and 8. Or 1, 2, 4, 7. And then you'd have 6 and 8 removed. You'd have 3 and 5, 9. If this is a 7. Ah! Which means that I can't have 3 and 6 anymore. Because if this is 3 and 6, this is a 9, and this is a 7, and where do I put the 3 in here? Not here, not there, and not there. 3 and 3. So that would contradict. So this is forced to be a 1, 2, got a 1 here. This cannot be a 1, and I can still do 1 and 3 for 7. Or I've got 1 and 2 and 4 and 5 for not 7, for 9. One and 3 Well, if these are both 3, then that's a 3 and a 4. Which is fine. Five, 1, 3. 3, 1, 3. Or 3 and 1, 5 or 2, 4. Those are both 3. That's a 3 and a 4. Excuse me. 2 has to be one of these 2 on the bottom to combine with this 2 and that one too. So then 2 here and here force 2 in this group. So this isn't a 2. If these 2 are 2, then you have to have 2 as one of these, and then that would have to be a 2. Which doesn't look like it breaks anything. This cannot be a 2 because 2 doesn't connect to itself or 8. What is the 3z plus x? Is it just these z's? Probably.
Must be.
We're approaching 10 o'clock,
Yeah,
so do we need to hit the stop button here?
probably.
Okay. And we'll come back to this on Thursday.
Yeah.
Alright. We'll pause here. And that will be it for today. Screen end.